All right, here I am today, finally putting back this power supply for the Epson. What's it? Anyways, let's start with this. Let's see if that looks good. I like it. I'm gonna go with the rest of them and get them all in. All right, let's figure out how to get these held up there into place that we want them. I am just going to go with set up the base, and then I'll go with the rest. Put a little flux on there. Whoa, I am not on. Shoot. All right, we're going to have to pause this for a sec. All right, we're back. I finally got the soldering iron heated up and ready to go. So a little bit on there, and we can straighten this to where we want it. Nice and flush with the top. I guess that doesn't really matter which where I put it, so I'm just going to make them all the same. And for people like me that are lazy, it's easier to not have to trim stuff later. Make adjustments real quick. There we go. You run the solder to the opposite side of the heating element, and it sucks itself towards it. You don't use the heating element to melt the solder, ever. Solder. Nice, quick, easy. Yeah. Looks like I got a bit too much flux, but flux is cheap. At least mine is. There we go. That's all there is to it. We'll plug this in and see how we're doing. So these are all NPN, so they should be switching right there. I wonder why these switches here. Oh, I'm on the wrong side. There we go. So the switches are all good again. And that's what I expect to see on that side. Oh, wrong one. There we go. So we got some capacitance and resistance in there, what you can see. That little round area is the capacitance, and the up curvature is a lot of the resistance. So we can check a capacitor right here, and you can see how it works. There's a capacitor there, and this is probably the resistor that's running that right there. So the caps and resistors are all looking good. I'm not sure what these are. These are NPNs as well, so I guess I have replacements if I need them. Or N MOSFETs, sorry. I keep calling them transistors and everything, but they're I just generalize everything. See what else is there to test. Let's just test the input and see what happens. Capacitance, capacitance, capacitance. And it doesn't care which direction it's coming out. Capacitors are good. I'm good to call this finished, and we'll install it and hope for the best again. So I'm on a diode right now, and it's got some great switching and capacitance. So let's test it and see how it works. Here we are trying to fire it up for the first time. Hopefully I got it all fixed, but let's see. Come on. Says it's powered on, but I don't know. Oh no, what is going on now? Oh no. All right, I guess we better troubleshoot further. All right, we are back after you've seen that failure. Not quite a complete catastrophe. I still believe that this is actually working, but this is not the power supply. This is the high voltage. It's probably the ballast for the light. But I tested it and all looks good. But then I got to the actual power supply, and how do I know that? Well, it dummied it down for me. It says right there, AC power supply. So I'm quite sure I have the right one this time. Anyhow, we'll just look it over real quick. Right here, these look like MOSFETs or something, but they are definitely not. These are double diodes. I will be working with those a little bit later. Anyways, I start with checking those because this power supply has 100, well, what is it? Mains power coming in right here. We have 17 volts coming out right here, and I believe a 19 volt was coming out here as well. Then we have a 15 volt coming out and 380 volt DC coming out right here. So we could plug this in and check all of these output voltages, but before I start anything, I like to just look over what I have, check some capacitors, find out what's going on with these. Can even check those. This is just a ferrite bead right here. Same with here, I believe. That's just to get noise down. But anyways, let's start with the double diodes here. This is basically converting it to a bridge rectifier, so I'm sure that this is an output voltage right here. I'm dropping it down to, I don't know, maybe 17, 15 volts, somewhere around there, which will then convert it right here in the DC to these double diodes. So I believe it said center was, yeah, it's going into towards center, so we put the positive into the center. And you can see we're getting capacitance, and that's pretty much it. As it floats, that's the capacitor going, pulling it over. Oops. So let's check the other one is right there. You can see it's just capacitance. So We don't have much going on here, so I know for sure, I'm quite positive that these are bad. But we also have some FETs right here, and I believe they tested good. Yeah, they are testing okay. But we have a diode right here, and that is just straight capacitance. I don't like that either way. And I have to take this whole thing down just to get to this one here. We have another FET right here, and it's switching okay. We have some downwards voltage showing like as if we had some Zener going on, but we have some reverse voltage in there, which is interesting. We have some optocouplers here that shows a lot of resistance. So let's see. No, not really any capacitance there. It's all resistance. So there's a capacitor there. I believe that's because this is the opposite side. So I expect that. What else do we have to look at? Capacitors right there, which I can get to right here. So these are just DC capacitors, so you don't actually get the round curve. They always just side shift, phase shift, basically. We have those. Maybe I can get two. Nope. Anyways, we'll come back. We're going to leave this as a cliffhanger. I'll get some parts looked at and ordered and make some more videos on how this goes.